As manufacturing evolves, so has the process of measurement and metrology. At AAT, we are the leaders in the next major step in the evolution of measurement. In the beginning, manufactured goods went from design to manufacture to dimensional measurement equipment. Parts were generally designated as good or scrap or rework. As things evolved, eventually the results of dimensional measurement were fed back as inputs into the design and manufacturing process, thus closing the loop for quality. By utilizing probing directly on a CNC, a true in-process measurement is accomplished. This produces a shorter control loop and allows per-piece changes without operator involvement. CNC measurement should be considered as a complement to CMM technology. We have shown dramatic time savings in first piece inspection by reducing the number of trips to the CMM. Oftentimes, parts that required several trips to the CMM have been reduced to 1 or 2 at most. This reduction in CMM workload can oftentimes result in hours of time saving, and production increases as CMM wait times are reduced. CNC probing is replacing dedicated gauges more and more. Dedicated gauges tend to be very expensive and very inflexible to part change. Soft gauging, by using CNC probing, is much more adaptable and allows for quick and easy changes. When AAT began to look at on-machine probing with CNCs, we realized quickly that the current state of this technology was very difficult to understand, program, and manipulate. At AAT, we set goals related to on-machine probing. Our goals included setting work and tool offsets, generating inspection reports, and collecting SPC data. All this needed to be done with an easy-to-use interface based on a CAD environment. As a result, CAPSnC was created. CAPSnC allows the user to create DEMIS inspection programs offline from CAD models, post-process these programs into CNC code, then run the programs, analyzing the data, and many times using a real-time interface. This interface also allows data to be fed back into the CNC to correct a process. Ultimately, a completed inspection report will also be output from the system and can be stored into SPC databases or to a network environment for later use. AAT also looked at the various sources of manufacturing error and highlighted just a few. As a result, we determined that nearly all of the common errors resulting in out-of-tolerance parts were detectable through on-machine probing. Further, we found the use of an artifact or known part allowed customers to gain confidence in manufacturing capability as well as measurement capabilities. One example of an application using CAPSnC is large mold and die manufacturers. Moving large molds and dies to be checked by a CMM takes hours, and setting these parts up to make corrections is also extremely time-consuming. Getting a blend after resetup is nearly impossible. Completing measurements on the CNC cut several hours of most of these processes. Another application was trimming wings for commercial airliners. In this application, CAPSnC adapts the cutting program to the existing shape of a wing ready to be processed. Another application where CAPSnC was used was during a multi-op manufacturing process of engine blocks. In this application, we were able to successfully measure all manufactured aspects of the engine block in each operation. We were able to also feed SPC data back to a plant management system and provide trend analysis, which in this case allowed for scheduled maintenance as machines changed in relationship to the fixtures. We also were able to maximize tool life by monitoring critical holes and features. As you've seen, some of the benefits from probing on CNC machines using CAPSnC include enhanced part setup, extended tool life, elimination of errors by manual input of data, increased productivity, reduced reliance on the CMM, and final inspection reports generated at the operator station. As a highlight, CAPSnC connects to any machine tool up to 5-axis. Provides an offline probing environment, provides graphical simulation with full collision avoidance, provides complete GD&T, and generates final reports with a real-time interface to feed back measured results into the CNC.